Soldering and welding is the title of the next lecture for today. Uh, Removed by Saja framework made of metal may susceptible to fracture or fatigue in one of its component. And to repair them, we need to use a proper method, either by adding component or by fixing the fractured or detached or fatigue parts. So soldering and welding, in this lecture we will discuss that. Soldering is a process of joining metals by the use of the filler metal. That means we have the two parts of the fracture framework and then using a filler metal inside between them, which has a substantially lower fusion temperature than that of the metal being joined. So in terms of the cobalt chromium, for example, melting point, we should consider that the third filler metal should be in the melting temperature lower than that, to make sure that we will not affect the composition and the properties of the framework itself. If the fusion temperature of the filler metal used exceeded 450 centigrade, and then the procedure is called as brazing. So if the filler is lower than 450 centigrade, so it's called soldering, while if the filler is more than 450 centigrade, this will call the brazing. So if we just has any information regarding brazing or soldering, so this is depend on the filler material that we are and the melting point of the filler material between the two joint metals or fractured parts. Now, the requirement of the soldered metal should have the following properties. It should diffuse safely below the sag or creep temperature of the parent alloy. The solder, that means the filler that we are using to join the two parts, so it should be fused safely to the parent's alloy. That's mean the for example the original alloy of the framework. Now it should resist tarnish and corrosion. Of course, we do not looking for solder the properties lower than the two parts that we would like to join them. It should be non-pitting. That means flow gently, and after cooling there is no pitting on it. It's maybe either expired or the process of melting it into gap between or the two parts, or to join the two parts showing pitting. It should be free flowing. There is no obstacles on with the flowing of this material, and also it should match the color of the parent metals. If this is, for example, cobalt chromium, it should be gray. If gold alloy should be yellowish, and so on. The joint should be strong. Now, the soldering, we have also the soldering flux. The flux meaning flow. What that mean? Allow the solder to flow over the metal surface to be connected by preventing the formation of oxides on the metal surface during heating. So the part that we would like to join in terms of soldering process, we should put a flux on it. This flux on this part we would like to join, this will increase or enhance the flow of the solder material to these parts without producing pitting or obstacles there. This by preventing the formation of oxide on the metal surface during heating. Oxides prevent the solder. Of course, the oxide prevent the solder from wetting and coming into contact with the metal surface. So for this, the function of the flux, first of all, to protect. So it is a protector. Why? It covers the metal surface and prevent oxide formation. Okay? Now, reducer. What does that mean? It helps to reduce the oxide present on the metal surface, even with the highly polished, still after using or there is an oxide. So it's like cleaning the area that we would like to join by using solder material. Also, it's a solvent. It's a solve any oxide present on the surface that we would like to join and remove it. The composition of the flux, generally it's borax glass, about 55%, and boric acid, about 35%, and silica 10%. A borax type of flux is used when gold alloy are soldered, while fluoride type of flux used when chromium cobalt alloys are soldered. And this is related to the composition of the material of the flux itself. Now we also have anti-flux. The anti-flux is used in aiding for controlling the flow of the solder. So the flux placed on the parts that we want to join, but the anti-flux placed on the parts that we don't like to the metal to go through or to adhere to it. So any area that we should be determined for the soldering. So behind this area or the point or the line behind this, the anti-flux material placed to avoid overflowing of the soldering into this area. And common anti-flux are graphite, it's a pencil lead, or priority anti-flux paste. Sometimes we are using paste and sometimes we're using the pencils to provide an area or demarcation line on which the flowing of the flux are not going there. Soldering investment. Since we are going to solder parts, so the other we need a base for the two parts to be joined. We do not use wax or any materials that or sticky wax that we are usually used with in term of repairing polymers and resin. With the metals, we should use soldering investment. These are silica bonded investment that contain fused quartz, and fused quartz is used because it is the lowest thermal expansion form of silica. This give a base for the parts and to hold the parts in place and to avoid distortion of the framework while we are exerting the heat in terms of soldering procedure. Now, what the types of the soldering that we have? Three main types in soldering, and nowadays we have many techniques and many companies have many machines and equipments for soldering procedures. Starting with the oven soldering, this is furnace or oven soldering is performed under vacuum or in air. Now, a piece of the solder is placed in the joint space and it is heated to a standard temperature in the furnace. Now, the major advantages of this solder is that they produce a superior joint strength. But the disadvantages, the parent metal will suck or melt if heated for a long time because the oven is not in a specific area or point regarding the soldering. And this is the advantage of this type. Now, the torch soldering, and this is the most commonly we used it. Here the soldering is done under a direct flame. A gas air, as we mentioned previously with the torch in terms of melting metal, we have also a manual torch with a specific zone with the reducing zone to exert it in the point, and the orifice of the torch will be different in terms of melting metal for the casting procedure or for soldering. Now, a gas air torch is used for this purpose. The torch flame has two parts, namely the reducing part and the soft brush part. The reducing part is at a higher temperature compared to the soft brush flame. We discussed the part of the flame of the torch flame in the casting lecture, so you can retrieve the lecture and find out and refresh your memory in terms of which zone is particularly for heating. The solder should be melted using the soft brush flame. The flame should be constantly swept over the solder for a period of 4 to 5 minutes. At no point of time the flame should be held in a stationary position. That means it could be moved. This is the most applicable and the most commonly used technique using torch soldering. Infrared soldering is one of the more advanced technique in soldering pieces to repair or the fractured pieces in terms of metal frameworks. Also, it's used for jewelries as well. Sometimes it can be used for low fusion connectors. Good accuracy is possible and the heating is controlled. Joints have similar strength as conventional solders. A protective eyewear is necessary for the operator. And actually this is the most effective technique to be used, as it is a spot one area or line will be soldered. Repair by soldering: approximately 80% of the soldering in dentistry can be done electrically. Electronic soldering permits soldering close to a resin base without removing that base because of the rapid localizing of heat at the electrode. So it is essential if we have, for example, minor connector close to the resin denture base, we need a spotting soldering like in electronic soldering. Solder for gold alloy that melts at between 1420 Fahrenheit and 1500 centigrade Fahrenheit. While the solder for cobalt chromium alloy, which melts at about 1676 Fahrenheit degree. The following is actually the procedures between the electric soldering and the torch soldering is that the rough we should rough both section to be joined. Okay, in term of adhering, giving enough mechanical retention for the soldering material. Adapt platinum foil to the master cast. We should have the master cast to be retrieved now in this stage, and to use a platinum foil over it before and beneath the framework to serve as a packing on which the solder will flow. We don't want the solder to flow into the cast, and this will give adhering to the surface of the cast stone because of the porosity there. Now lifting the edge of the foil to form a trough to confine the flow of the solder. Now then we seat the pieces to the solder and to the master cast and secure them temporarily with stick wax, because we are using investment material. So it is temporarily we stick them together. But in terms of fatigue, we don't need a sticky wax. It's only to combine them. It's already combined and there is a fatigue between them. But in terms of fractured, we should use a sticky wax to combine them over each piece, and then enough soldering investment to secure them after the sticky wax has been eliminated, but we should leave as much metal exposed as possible to the soldering procedure. After flushing off the sticky wax with the hot water, of course, we secure the cast to the soldering stand, cut sufficient solder, and place conventionally nervy. Flux both section that we would like to solder, with sufficient triple thick solder or on it or in the joint to complete the solder in one operation. Do not use uh, um, different or many steps. It's one quick soldering step. Whether you are using electronic or you are using a blowtorch, uh, the process should be at once in one step, always starting with enough solder to complete the job. Do not use shortage soldering. This will lead incomplete soldering, and this will affect our process, and then we will need to remove them, polishing and fluxing, and the steps will be more complicated to clean the incomplete soldering. With the carbon tip with water to avoid conducting of the current, and then touch the carbon tip to the solder. We should be sure that the solder is held firmly in place in terms of electron. This is electronic soldering. Place the other electrode on any portion of the framework to complete the electric circuit, and heat the carbon electrode. Do not push the solder with the carbon tip, but let the heat alone make the solder flow. Do not push it. Do not remove the carbon tip from the solder while the solder operation is in progress. This will cause surface pitting due to arcing. After the solder has flowed, remove the electrode, removing the carbon tip electrode then, and proceed to remove the work from the cast for finishing. The torch soldering probably requires an entirely different approach. Uh, the steps with the electrode is by using electrode, anode, cathode in terms of current circuit, and the solder will melt into the proper position that we would like to solder the two parents parts of the fractured or detached component. In torch soldering, this will be different. Used when the solder joint is long or usually bulky, and then a larger quantity of solder has to be used. Uh, Torture soldering cannot be undertaken to repair or remove a washer denture framework that has resin denture base or artificial teeth supported by resin. So if you have a fracture in the framework underneath the resin, we shouldn't use the blowtorch. However, still, the procedure for the preparing the parts in terms of roughening the surface, platinum foil, seat the section, careful remove, assembles, adapt the stock or utility wax on it on either side. After boiling them, the investment still remain. It's the same as electron. The only thing is the investment, the casting, the sufficient solder investment to secure it is exposed as much of the area to be soldered as possible. Then the investment set then place the investment in drying oven, not exceed 200 Fahrenheit until the contained moisture has been eliminated. We do not dry or preheat the investment with a torch, because oxides then will form that will interfere with the flow of the solder. We use, of course, the reducing part of the flame and exerted on the which is federally part which outside the blue inner cone. we should remember to flex the joints, anti-flex the parts that we don't want to 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 be soldered. Heating the casting until it is dull red. This is the main issue with the blowtorch or manual blowtorch soldering. We heat the casts before soldering it at this point, and then until it is dull red. And then, while holding a strip of solder in the soldering tweezer, dip into the flux and freed it into the joint. While the casting is being held at a dull rate heat with the torch, once the soldering operation has begun, do not remove the flame, because any cooling will cause oxides to form. The heat from the casting should be sufficient to melt the solder. Therefore, do not put the flame directly into the solder, because it will become overheated and bitted with the bitting will result on it. After the soldering has been completed, allow the investment to cool slowly before quenching and proceeding with finishing. Remember that any soldering operation that heats the entire casting is in effect a softening heat treating operation, and heat hardening of a repair called alloy casting is desirable to restore its optimal physical properties. This is all the details related to the soldering procedures and the types of the soldering. The other method that we have also to join the fracture parts or the fatigue part is the welding. Since the soldering is the joining two metals using filler, that's mean a third part, in the welding involves the joining of two or more metal pieces directly under pressure without the introduction of intermediary or filler material. This process, the type of welding is either cold welding, hot welding, spot welding, and laser welding. Now, with the cold welding, it is a process of plastically deforming a metal, usually, of course, at room temperature, combined by strain hardening, for example, gold foil filling. This is like a ductility and malleability of the material. While the hot welding uses the heat of sufficient intensity to melt the metals being joined. In the spot welding involves both heat and pressure. These two are the basic principles involved in the process of spot welding. For example, joining the orthodontic components. And the last one, which is the laser welding. It is done to join titanium components of dental crown, bridges, and partial denture frameworks, of course. Because of its low thermal influence, they are more preferred in dentistry. Since low heat is generated, the bars can be hand held, so we don't need to use forceps, for example. The maximum penetration depth of the laser welding unit is 2.5 millimeter. The superior joint strength can be obtained with it. And the procedure for the spot welding is in term of select of proper electrodes. Select the proper electrodes for the thickness or the shape of the material to be welded. For welding thin material, a broad electrode should be used for thin material. For thick material, a narrow electrode should be used for thick material. Cleansing the electrodes of the welder are cleaned so as to remove any carbon participated. Now, the surface of the electrode must be smooth, flat and perpendicular to its long axis. The metal being joined are placed between the electrodes. The electrode pressure can be maintained for a few seconds after switch is turned on to help to obtain a good joint, of course. The procedure of the welding using the spot welding is it's really helpful in terms of fracture points close to the resin parts. Now, what the factors that influencing welding procedures regarding the method or the type of the welding is first of all the current flowing through the circuit, since it is a spot, so there is a current electronic current, so it's the current flowing through the circuit, then the time during which the current is allowed to flow, and finally the mechanical pressure applied at the welding heads as these two bars joined. But put in your mind, in your mind, and bearing in mind that the soldering, the welding of two parts, that means using the material of the two parts to press together. So probably you may face problem in seating these parts later on, so you need to modify them. The quiz for the next week is what are the factors that influencing welding? Prepare them for next week. So this what we have with the soldering and welding this week. Thank you for your attention. Take care and see you next week.